All right, happy Thursday. So the first part today, we're going to talk about Project Zero. So I'm going to go over my solution. It's okay if it looks different, right? There's lots of different ways to go about writing code to solve the same problem, and that's okay. Right? As long as it gets the job done, we're fine. But I want to go through how I would go and solve it here. Looks like we only got, now 10 are, okay. Wow, in the last 5 minutes or 15 minutes, 5 more got submitted. That's good. So let me fire up PyCharm here. So we'll do this first, and then we'll talk about the array-based lists, which is really boring in Python. I apologize. Hopefully you didn't fall asleep during watching the YouTube video. It's just, we already have list, and list is just good. So anyway, so this is Project Zero. Oh, not in GitHub, sorry. I gotta put that in the right folder here. Come on. GitHub. CIS 2001. And then we'll call this Project Zero. Oh, my hands are cold. It's cold out. All right. It's fine. All those things are not so helpful. All right. So here's the main PY file. We could throw the classes right in here if we wanted. We can make another class to store them in. We could do one class per file. Any sort of approach is fine. I like having separate files for classes because I think it makes things look a little bit nicer in GitHub. It's just a preference, right? So it doesn't really matter how we go and do it. But if I make separate files here, like for unit here, then I'll have just the unit class. So I can have class for unit in here. Let me make that bigger here. So we define our init method. Now, unit has a bunch of attributes, right? Because everything is a unit. So we're going to have a lot of these different attributes in here and the given types that they are. So I expect a bunch of these things. So we can say, hey, I want an attack power. I expect it to be an int. Again, that's just optional here, but it's a nice little hint to tell us what it should be. And then we should have a hit points, which should be an int. And we can have range as an int. I can just copy paste these, can't I? Range as an int. We can have X position as an int. We can have Y position as an int. Come on, slide over. We can have, why is it upset here? The team as a string. And then we can have our is alive as a Boolean. That might be, is that just bool? That's just bool here. Int, where is it upset now? Oh, int colon, no, comma, there we go, I had a period. Okay, I have range as an int, I have, it doesn't like this one because we also have a built-in range. It's probably okay to change this one. Team is a string, there we go. String. Why is it not like that? It should be fine. We'll try in a second. So now I want to set these values as private attributes. I don't want anyone else to go access these outside of my public function. So we say my attack power is the attack power. My self.hitPoints. Hit points. Oh my goodness. My fingers are so cold from just walking outside. It's just sad. It's not even like freezing out. It's cold. Self.range is the range, self.x position equals the x position, self.y position, the y position, self.team is the team, and self.is alive is alive. Is that all of them? I think that's all of them. This doesn't like the string. Team is a string. Is it str? It's just str, sorry. There we go. So now I've got my attributes, right? So I can create a unit, it'll have all of these attributes. Then we need to add a function for attack. We need to have a way to move. Okay, so we can define a function for attack, given a target. So given another unit to attack, let's go do something and attack them. And then a move function. We probably need to know X or Y, right? Got a couple different options on how we want to do this. So I like the idea of saying we'll do X move and Y move. And just an option. So when we move x move and y move, we'll take my self.x position, I don't know, plus equals the x move, and we'll take the self.y position plus equals the y move. Okay, so we can move some x, some y. That's an option. So for attack, then, we need to make sure it's within range, and it's someone we should fight based on the team here. So, again, I like helper functions, because that makes life a little easier to break this up into smaller pieces. So we're going to say, hey, if target dot is within range, self dot is within range given the target, backwards here. So we'll make a helper function to see if it's within range, right? And self dot should attack the target. Then we'll go and attack them. So if we should do those things, then I can take my target dot hit points and we can subtract my attack power. And if we tell target that it is a type of unit, I think our type ahead works a little better here. Right, unit. There we go, come on. Why is it not like unit? No, we have that. Is it unit.unit? No? I think it's just confused. We'll see if that worked in a second. So now we need these functions here. So let's go add the method for it. So is within range, we're going to return my self.range, my private range, is less than or equal to the distance. Greater than or equal to the distance, right? So the distance between the two is math.square root of my self.x position minus the target.x position. Position. I want the type ahead to work. Here's a type of unit. Is that going to work for us? Target.x position. It doesn't work. Why is it so cranky? Then we got to import math here, right? Import math. So take that squared. So either copy paste or math.pow. It's probably easy. Power of 2, right, plus, and then same thing again, but with the y's. Y position minus the y position. Right, all that gets square rooted. So if my range is greater than or equal to the distance, right, between the 2 points. And I'm just going to,
So you did a square root and then square?
So the square of the x differences and the square of the y distances. Okay, we're just doing the distance for a hypotenuse.
So it's like, but wouldn't we just do it without them? Like just like, it's like the x position where you are at currently, and then the target's x position. You minus them.
Yep.
And if your range is greater than that, it should hit, right?
Well, no, because it's a triangle.
Yeah.
Right. So it's not. We don't just shoot in a straight line, right? I can anywhere in my 2D grid, I have within range. Right. So my range effect is it gives me a radius of where I can hit my targets.
Oh yeah.
So we just do the little triangle theory thing here to get the distance. Why is it not like unit? Create class unit. We did a class for unit. Super confused. What is it? What does it do if we create a class for unit? We did that. All right, it's just being dumb, I guess. All right, we'll see if it works. Anyway, so should attack here then.
Is it because of like the column?
I don't know. It's all tabbed in, right?
No, because like a column shouldn't it be like a equal sign? I don't know.
Oh, the colon? No. So this is like the type suggestions in Python 3. We looked at these briefly to say it should be this type when you call it. It's just optional, but it's confused why it doesn't work for us here.
Like you're saying that the target should be a unit.
Yeah, yep. We did that. Install import package unit. Unit.unit? What is it? I don't know. I think it'll work in a minute. All right, so then should attack. Now we need to have different teams. So if we have some different teams, an easy way to do this is some static values. So I can say, hey, team us is us. Team them is them. And team chaotic equals chaotic. Chaotic. That's probably spelled right. So I can use these static values. Now, these are not super efficient because I'm going to use the string everywhere, it's a little bit better to use enums, which map values to numerics, because numerics store a little bit better. For our purposes, we don't really care. I mean, thousands of units, strings won't even really matter much, but it's slightly less efficient this way. Doing the enum thing it's not much harder, but this is fine for now. Anyway, so we'll say, okay, so we should attack. So we're going to return the self.team is equal to unit.chaotic. If we're chaotic, we attack everybody. Right? Doesn't matter who. Or my self.team does not equal the target.team. Team. Right? If I'm chaotic, I attack everyone, or if they're not my team. So if I'm not chaotic and they are my team, I get false and false. The whole thing's false. I should not attack them. Right? Again, lots of different ways to go about that, but that's the quick way. Right? So if they're within range and we should attack them, we'll take away their hit points. The other thing we're supposed to check this if is alive status. So I can say, hey, if my target dot hit points is less than or equal to 0, target dot is alive is false. Now they're dead. We killed the target. Now, some games don't like negative hit points, and they would put that back down to 0. That's an option too. So we can do that. Target dot hit points is 0. Just depending on how you, like, if you're going to have a little display for health bar, negatives usually screw up displays if you're not careful. So we can do that here. This is, totally optional. Optional here. Okay. Now, depending on what we want to do with our logic here, we might also want to check that we are alive. We don't necessarily want to trust people to do the right thing. So in our code, we could also check to make sure our unit is alive before it attacks. Right? So like should attack means that, self dot is alive and all these other things, right? Because that way, if they somehow manage to call the attack method on a unit that's dead, we won't do anything. Just a little sanity check, right? This was optional, but probably makes sense in the scheme of things. And then I'm going to add some parentheses here. I don't think we need them, but it's just nice to be explicit here that this one or this one, right? Should be fine. Okay. So I think that's it for unit then, right? We've got our values, we have our functions. Now we need to start extending this class. So that's the base class. All of the logic here is done. Now we need to make types of units, special types of units. So infantry is special, that its attack power is 5, its hit points is 5, and it can go no more than 5 units for X or Y. So make a class for infantry. And again, I like adding new files for things. That's okay if you don't, infantry. So I'll import or from unit, import unit, and I'll write my class for infantry, extend unit. So it is a type of unit. Right, from the unit module. Again, I just like how it looks in GitHub. If you put it all in one, that's perfectly fine, doesn't matter. So we're going to define our init method. Now, what we need to know for infantry is all of these values for unit, but we know what a lot of these are. We know what our attack power is, we know what our hit points is, we know what our range is. We don't know the X position, the Y position, or the team. Is alive, you probably don't even make units that are dead to start. So this one seems a little silly to take in the init method. So maybe we take that out and just say is alive is true. We'll say, hey, every unit starts alive. Right? We could do that. And then in our infantry class then, so we need to know what our X position is, we need to know what the Y position is, and we need to know the team. The other things we know what they are already, so I can call my super.init here, and I can give it all those values. So all the values, right, it's going to be, what was the order here? Attack power, range, and string here. That's an int, and an int, and a string. Okay, so we're going to give it all those things that it wanted. So its attack power was going to be 5. Its hit points was going to be 5. Its range was going to be 1. Its X position will be the X position argument we're given here. The Y position will be the Y argument here. And the team will be the team here. Right? Unexpected arguments. Really? X position, Y position. Did I do it wrong? What did we do wrong? I feel like it's just confused right now. 1, 2, 3 ints, and then x, y string. 1, 2, 3, x. It should be fine. So that's infantry. The next thing that it does special is it moves, right? So it takes an x move and a y move. And now we had a max number of moves, right? We could go no more than 5 units. So we can have this in here. We can have a max move units or something like that is 5, right? As a static variable of unit if we wanted. And we could check, hey, if my x move is greater than, now, because this is going to be positive or negative, right? If you want to go left, we'd give it negative x. Again, this was an option. You could have different ways of writing move here. I really want the absolute value here. So I want the absolute value of x move. If that is less than my max move units, self dot max move units. There we go. If it's less than or equal to that, right? Max move, then I would move that distance, and we could either throw an exception, or I think it's probably actually even easier, right, to say if it's more than that, we'll just move the max, right? So maybe we flip this around. Maybe we'll say, hey, if this is less than or no, what am I doing here? If it is greater than that, then we'll take x move and we'll set that equal to the self.max move units, right? If you tried to move more than 5, we'll just say you had to stop at 5. That's one option, right? We could throw an exception if you tried to move more than 5, or we could just do nothing, whatever we wanted to do here. So I think ours, we were just going to choose to move the max. Okay, so we can move, right? No more than the max for our x move. Same for the y, but we wanted to do this on a straight line, right? Either x or y at a time here. So we need to check to see which one we were doing, I guess, right? So we can say, hey, if x move, right? Then let's set our x move and then call self.move given the x move and 0 for the y move. Does that make sense? So if it's a non-zero value, right? This means x move is not 0. If it's 0, it'll be false. Anything other than 0, hey, you probably wanted to move x. Now, if they tried to move x and y, well, they're out of luck. So again, we could add some checks in here and tell them they're doing invalid things, or we got lots of choices. We can say, hey, if x move and y move, raise an invalid or argument exception. Is it argument? Value error. Can't move x and y. I don't know, something like that if we wanted. Right? Otherwise, we'll just move x. And if it's not x, then it must be y. So we use the y move, We go 0 for x and move the y move. Right? Lots of different ways we could handle this. Right? And I'm okay with any of the approaches you took. Right? This is just saying, hey, we're only going to move one direction, x or y, and then no more than the max. Right? Sure, that's an option. Okay? So I think that's infantry. Right? Now, the other classes are actually pretty similar to this, right? So artillery, pretty much, but now their move is 1, their hit points are 1, they have a different attack power range. Okay, we can do that. So let's make a new class here for artillery. I'm just going to copy everything in here for a minute here. So here's artillery. So its max move is 1. Its attack power is 10, range is 10, right? Hit points is 1. Oh, is that what I did wrong? Did I do the hit points wrong? What was unit? Attack power, hit points, range. Attack power, hit points, range. Artillery. Attack power, hit points, range. Okay, there we go. We got that in the right order now. Okay. Now, is this still the same thing? If my max move is 1? Like, the code's identical, right? So I kind of feel bad about having the same code twice. That's our rule of thumb. If you have the same code twice, you should feel bad about yourself. So there's a way we could handle this. Yeah, we can change it, right? We don't need to have the same code twice. So I'm going to take it out of infantry here. Let's put it up in unit. Now we don't have the move anymore. We'll fix that in a minute. We'll take our self.x position, and we'll add the x move. In self.y position, we'll add the y move. Right? But now what is my max move units? Well, I don't have that, so I need a max move units. Right? I can have a self.attribute for this here. So in my init method, I could have an attribute for my max move units and pass it in as an argument. Max move units as an int. So I can say, okay, you tell me what the max move is, because move is identical here for that. So then infantry now will pass a max move. Let's see, that's max move of 5. Right? Or we could even give it a name here, right? That might be fun. Give it the max move units. It puts a nice name to it here. Then we don't have random values here. You know, we have attack power is 5. You can have hit points is 5. Hit points, self.attack power. Range is 5, right? Self.range. It just makes this look a little cleaner, right? So we've got these static values here in our class that we can use. We have nice names for things. Totally optional. It does the same thing, but now if I want to go change it, I have a nice name and I know what I'm going to change here, right? And I can do this then for artillery. Right? It doesn't need any of this. All the same stuff is the same, but its move units is 1, attack power is 10, hit points is 1, range is 10, right? Now, artillery is done. Nothing else is different, right? We just pass the different values here, right? And then for cavalry, right, we have 10 move, range is 5, attack power is 5. So we'll add a new Python file for cavalry. Right, we'll copy artillery into cavalry. Cavalry given a unit. Here we just change a couple values. So its range is going to be 5, its attack power is 5, its hit points is 10, and its move is 10. Right? That's a cavalry unit. So my 3 units are actually really boring now. The only thing that's different is their values. Right? Because everything else, all the shared logic is here in unit, which is the way we want it to be. Anything that's shared can go in that parent class. If it's different, if it's special, a special version of it, put it in there. So the last piece we need is the captain class. So captain's special now. So captain won't be identical here because captain is an infantry. Okay, so from infantry, we're going to import infantry. That's the captain class. Now, it does all the same stuff as before. And the init method we're calling is the infantry init method, not the unit init method. So infantry init needs X, Y, and team. So captain needs X, Y, and team. All the other stuff happens the same way. Now what's different though, right, about captain, is they have a different attack power and different hit points. So now we can go change those values. I can say, hey, self.hit points is 20 and self.attack power is 1. And go change those. Why is it not like... I think it's real confused. My PyCharm's upset today. Okay. Let's see. Oh, is it upset with 2? There we go. Go fix all these. Cavalry. Did I spell it wrong? Oh, Calvary. Okay, good to know. There's an A there. Did I spell it right over here? I did. Okay. That must have spell checked me. All right, infantry. That's good. All right, so captain. What's different about captain, though, now is its attack method. So given a target, which is a type of unit. Oh, is that why it doesn't like unit? Is unit a predefined name from unit or unit? Maybe? Oh, it likes it here. Okay. So captain then will heal someone if they're within range and on their team. So we can say, hey, if self dot is within range, given the target, right? And now if they're on our team, so self dot team equals the target dot team. Now, how do I put a unit back to full hit points? Well, I don't know what their full hit points should be, so we probably need a way to track that. So we can go back to the unit class, and maybe we want to add a new variable here. So maybe I have a self.max hit points. Probably starts at their hit points. Right? Whatever the hit points was is probably their max. So I can set now, based on their max hit points, we can say, okay, if they're within range and they're on my team, target.hit points is equal to the target.max hit points. Right, give the max hit point value, set that to their hit points. Now the other piece, though, here is that targets might be dead. So depending on how you wanted to do this in the game, and again, this was open-ended a little bit on purpose. When we write code in the real world, it's messy, because you don't often get, here's the exact spec here, you get, this is what we want to model after, right? We're making code that looks like this. So should Captain be able to revive dead units or only heal units that aren't dead yet? We can either go ask whoever is making this game or we can decide for ourselves. So I think it makes sense to only do that if they're not dead. That's just a choice we made. We could say and target dot is alive. Target, right? So if they're alive and they're on my team and they're within range, then we can change their hit points. If we were going to revive dead units, we'd have to make sure that we put all their hit points back and then we set their is alive back to true. Right? Does that make sense?
Yeah.
Cool. So that's Captain. Why does it not like init here? Call to init if the superclass is missed. I didn't miss it. I did miss it. Oh my goodness. I was missing my parentheses here. Okay, my bad. That was wrong in all of them too. That's fun. Super parentheses init. I was ignoring all those lines here, and it was telling me I was doing it wrong. There we go. So unit, captain, infantry, artillery. Make sure all those lines went away here. Okay. I think those all look happy now, right? Except for this one. Why does it not like unit here? It's weird it still doesn't like unit. Create unit. I already have a class for unit. I don't know why it's confused. All right, we'll see if it works anyway. All right, so then in main PY, we don't actually need anything, right? Because we're going to write unit tests. But if we were, right, we could have, you know, us1 is, oh, we got to go import here, right? So we're going to import from unit, import unit, from infantry, import infantry, from cavalry, import cavalry. Now, this is why having like one file per class is a little silly when you do these imports. It's not very idiomatic, but I like having it for the GitHub history. And then from captain, import captain. Sure. So now, the us then, let's make this maybe is infantry. Right? And we'll put it at 1, 1, and that'll be unit.us. Right? Team us. And maybe like a them 1. How do we make that a cavalry? We put that at 2, 2. So unit.team them. Sure. Let's do 2, 1, right? Team them and a chaotic 1 is a, let's do another infantry at 2, 2. And we'll do unit.chaotic, chaotic. Sure, I mean, we could do lots of things, right? And then eventually us could attack. How about the chaotic, right? So an infantry should not be able to hit something at 2, 2 because the distance is more than 1, right? So nothing should happen here eventually. Right? Well, we'd have to, and that's what we'd have to do, like, and that's what we're going to do with the unit test code is, does anything change? Do we expect values to change or not? Their hit points should not change because they're not within range. Or if we were to try to attack our same team, right? If we had another us, we had an us2, is a captain given 1.2 unit.teamus. Right, us1.attack us2. Right, nothing should happen because they're our team. They're within range. And then us1.attack the them. This one should work because they are within range. Right, and this will, again, we're unit test here, but we want to make sure the code runs for a second here. Uh-oh, yeah, unit's not defined. Why? Is it self? No, unit.unit. Doesn't like unit. All right, I mean, it's optional anyway, but it's weird I can't do that. All right, let's see if that runs now. Uh-oh. Exposition. I missed my parenthesis, or my underscore here, right? Because that was not a public value. Okay, let's try it again. Attack the target. Nope, attack power. Take away my attack power. There we go. Yep. All right, I finally ran without error. So we've catch that all in our unit tests. So we're just trying to run it here to see what's not going to compile right. So it seems like it runs. And again, not very interesting yet. We didn't have to make this game part. We're going to make the tests now. Right. So we wanted to get the unit class tests, infantry class tests, all the tests here. Okay. So in unit, then, what do we need to test? Well, we need to test attack, we need to test move. These helper functions will get tested within the other ones as well. Right? And then infantry, artillery, cavalry, there's not actually any code in here aside from their nits. If you wanted to test the nits, we could. The other piece we're missing here, sorry, is the functions. Right? Do we have any public functions? So I made all these values private. So like self.get x, get y, those would be good things to add in here. So people can get our hit points. Get hit points. Return self.hit points. This sort of thing, so that we have private values with public functions with good object-oriented programming. It's just tedious to type all these things here. We can't generate those? We can't. That's obnoxious. Define get x position, return self.x position, get y position, return self.y position, define hit points. We could do attack power and range, get attack power, return self.attack power, define get range, return self.range, power hit points range, team, team, define get team, self.team, and then is alive. Now, for booleans, usually they're not gets. It's just a wording thing. Return is alive, because it's funny, like get is alive. I don't know. This is just a true or false. Yeah, we could get the max move units too if we wanted. I don't know. Depends on what we wanted to add in here. All right, but now we want to test it. So we're going to right click and say go to test. And create some new test methods. So what do we want to test? So anything that there's a function for, we can get tests. Let's see. So let's do move, attack. All the other get we'll use later. That's okay. And now I can actually test all of these in the same file. This is just the test file. We could have separate test files if we wanted. We could have one test file. Again, separate test files are nice, but there's not too much difference between infantry, artillery, and cavalry. Yeah.
In the industry, how is it usually done?
Different orgs might do it differently. My company used to do one file per class. You don't have to do that as just a convention. In Java, you have to do it in Java. Just other languages are different. So like stuff that gets grouped together makes sense to be all in one module. That's fine. Or you can just put stuff in a folder. I like the idea of packages. So I might have a package for unit classes or something. And then that would have all the individual Python files for the individual ones. It just makes the git history really nice, so you can see when the last time that class was changed. Because otherwise, every single commit will change that file. So I have to go look inside the file to see what changed that time, rather than I can see, hey, the cavalry class hasn't changed in the last 15 commits. That's probably not what's wrong, if something isn't working like we'd expect. So just a convention. Just some people like to do it that way. Other people throw everything into one file because you can. Like, I don't know. They both work. All right, so for testing the attack function here, now really attack we need to test a couple different things, right? Because we said it shouldn't do anything if you're not within range. It shouldn't do anything if you're the same team. And then it should change your health and change your is alive status if we got your health down to 0. So technically one attack that is within range, is a different team, and gets their hit points less than or equal to 0 will run all of this code. We'd have 100% code coverage, but it's not testing the other cases. So if you didn't have it, that's okay, but it's good to test the behavior you expect, even if that's a nothing should happen behavior. Because if it does change later, or if you have typos, right, just because we've tested in all the code runs doesn't necessarily mean our is within range is working. Right, so that's where these like, hey, they're not within range sort of things are good for us here. So we might be able to test some of these within range, not within range here. So let's do this as test attack, not within range. Within range. So we're going to arrange, we're going to act, and we're going to assert. So to do this then, we should have an expected hit points. Right, that hit points shouldn't change, so it should stay at 10 if we're not within range. Okay, and then we need us is a unit. Now I can use the unit class if I go import from it, so from unit import unit. I don't need to use the other specific classes yet. I can go test those out later, and it's probably a good thing to make sure I put the right values in because it is error prone, but that's okay. So for unit now, we need the attack power. I don't know, 10. Hit points is 10, doesn't really matter. The range matters now. So if range is 1, right, and we put it at 0 and 0, and then team is, let's do unit.teamus, and then max move is 1, shouldn't matter. Yeah?
So in this one, you expected not to attack the ones that are not within range, right?
Yeah, we want to make sure that if you are not within range, your hit points don't change. So that we know that our catch here is working, that you don't attack people that aren't within range. Like we're testing the negative case, not just the positive successful case. Because I want to make sure that I didn't screw up my is within range function. Because anytime I'm doing math, it could go badly, right? And that's a super easy place that could go badly. So
here in our range, we'll have both our units that will be attacking each other.
Mm-hmm. Yeah, so I'm going to make a them. There's a unit with 10, 10, 1. So if it's not within range, 1, 1 should not be within range of 1, right? Because the square root of 2 is more than 1, right? And this is unit.team them. Max hit point, max move is 1, sure, doesn't matter there. Right, I think we've got all of those. I keep doing periods instead of commas, okay? So that's the things I need to test. So then the code I'm testing is the attack code. So us.attack them is the code I'm testing, and then I'll get my actual hit points is going to be my them.get hit points. Right, you see how many hit points they have, and I should assert they're equal. So assert equal my expected hit points, my actual hit points. Did it stay at 10? Right, I guess I should pass that in for hit points here then, right? We'll do that expected hit points here. Right, so this one should pass if you don't take any damage when you're not within range. Now, if you do take damage, right, if you are within range, I can copy this function here. So this is attack does work. So if I do 1 point of damage, or no, let's change my attack power to, let's go 10. So you should have no hit points left, and then expected is alive should be false. Right? If I do all 10 points of damage to you, oh, I got to give it 10 hit points here, sorry. If you get all 10 points of damage for 10 hit points, your is alive should be false, you have no hit points left. Then actual is alive, them dot is alive. And then we'll assert self.assert equal my, actually you can say assert false, right? Because we'll say you should not be alive. You don't need to compare this to a false, I guess. You can save one line of code. Or we can say false equals false. Both ways will work here. Right, so this one should work if we're within range. So I got to fix one of these ranges here. So if I'm at 0, 1, that should be within range of 1. Or I could change the range to 2 or something like that. So I'll change the ranges to 2. Now I'm within range. So I run this one now. That one passes. That one worked. Now I could also have, if we're the same team, we shouldn't attack each other, right? My hit points should not change. Same team. So this is same team. So for both team us, and we are within range, right? 2 and 2. So it should be within range, but there should be the same team. Nothing should happen. So my hit points shouldn't change. That one worked. Right, so 3 different cases that I'm testing here. And one of them got 100% code coverage, but I want to make sure that within range works, the should attack works, and then the rest of it works. Okay, just to make sure that the code I wrote does what I expect it to do. Cool. And then move, right? Now, move in unit is not very smart, right? It's going to take the x and the y and move the x and the y. So a couple things that could happen. I could move x and y and get the value error. There's one thing I can check. If I pass it an x move, I should move that distance. Now, there's actually a bug in here because I'm saying if my absolute value is more than the max, set it to the max. But I didn't check. So if I said negative 50 and my max was 5, I set your move to positive 5. Right? So I need one last check here, right? So if my x move is, this is no good here. So if it's greater than that, right, set it here, and then before I do that, right, before, so then if x move is less than 0, right, I want a negative case or a positive case maybe, times negative 1. Or I can really do, I think I can just do negative here, right? Negative max, positive max. Right, we would have ran into that when we were testing if we tried negatives. But I cheated because I knew it was going to happen. Right, same with the y move. Y move, Y move, Y move. Right? So for testing move then, we want, I don't know, fails, I don't know, throws? Sure. So we're going to range, we're going to act, we're going to assert. So if it's supposed to throw an exception, right, we can test that it's supposed to throw an exception. This one's actually kind of fun. So we need a unit to test with. So let's make a unit. Right, sure, it's at 0, 0. We don't care what the hit points are. I don't know, 10, sure.
So theoretically, if the positions are 0, 0 for both, they are in range, right?
Yeah, yeah. The distance is 0 then at that point. Yeah, if you're both at 0, 0, the distance between the 2 points is 0.
So if you pull at 10, 10, 0, 0, then it's not in range, I guess.
If you're further away than the range.
No, so like if one unit is 0, 0, the other one is like 5, 5, then it's off range, I guess.
I'd be this, I don't know, whatever.
The unit, right?
It's square root of 50 is the distance, right?
Yeah. Okay.
Yeah. All right. So if we expect this to raise an exception, there's a couple silly things you can do. Self dot raises, I think. Assert raises. What is the exception? So it should be value error. I think this is it, right? Do we do this an example of this yet? The exception code?
No.
I don't remember if we did or not with testing. I think it's with. I always have to go look it up. Python unit test exceptions. Hey, first hit on Stack Overflow. It's got to be a good one, right? Come on. What's happening? Go, yes, go there. It's not even loading, come on. Right, can I just see, nope. Self-dot, okay, I don't need the width, so assert raises, so just assert raises. A value error, and this is gonna be us.move. So if we wanna move X and Y, like 10 and 10, it should raise the value error. I guess that's just, I guess it's technically in the assert, which is a little weird to put it here. Let's see if that one works. Uh-oh. It threw an exception. Yeah, we expected an exception, right? Raises. Value error. Let's move. Are we missing? Something's not right. Come on. Let's load. Stack Overflow's offline? Oh no. The internet's down. That's super sad. There it goes. Yeah, that's what I thought. We wanted this one with. Okay. This is the better syntax here. So we want with this, and then you can actually check the message here. Let's say with, there we go, as error. So that will fail here, and then we can go, oh no, just the exception. That's what I'm doing wrong here. Now we can call us.move. We get the error, and then we'll have a, if you wanted, then we can have like an expected error message. I don't care that much right now. I guess we can check it. Is, because we wrote it, right? We wrote it. Can't move X and Y. So we need to save our context as error. Okay, so then we'll self.assert equal my expected error message, my error, I guess we'll save it here, what actual error message. Actual error is error dot message, right? Or error dot exception? No. What's the message? Is it the exception? Something in here. We'll try it and see. Nope, actual error. Why is it failing? Let's try error. Error dot. Is it the exception? No. It's not equal value error. Oh, okay, so I wanted, oh, it's in. Sure, assert. True. So this is in the error exception. Uh-oh. Stack Overflow is failing us. Assert true. It's in. Turn this into a string. Here on the test. Hey, we'll get it eventually. All right, we've sort of got this working here. So let's leave a comment from here. All of this to test that we got an exception. That's super fun. A little bit gross, sorry. Does that make sense, what this one's doing? Okay. Then we can test the move actually works. Right, so move works, sure. So if our max move units, let's do like 2 here, just so it's not a 1, I don't know. We won't have an error, and then we'll have a expected X is 2. So if we start at 0, we move 2, it should go to 2. Right, or should stop at 2, I guess. So then when we act, then we can call us.move. How about we move like 10x, and it should stop at 2. So we'll have an actual X is my, or that's position, right? Position is my us.get X position, and we can assert they match. Assert equals my expected and my actual. So if I try and move 10, it should stop at 2 because my max was 2. right? Max move units was 2. So let's give that one a run. And that one passes. Right, so I get a bunch of green check marks. Life feels pretty good here. Now, 3 different attacks are working, 2 different moves are working. I know tests are super exciting, sorry. But this is good. We're making sure the code does what it's supposed to do, and I don't have to print stuff out on the screen and look at it. So once I've done that, not only do I not have to look at it, but as this code changes, as this game stays out there in the real world, because people love this game, and we have to live service all of our games now because that's what we expect to do, because every game should have seasons and seasonal battle passes and however you want to monetize it, whatever. Right? We could go and change our code. So the tests will make sure that we don't change behavior without intending to. So if the test stops working, we know we changed something that changed one of our expectations. So we said, here's the rules for what our program should do. Let's put them in the tests to make sure that it follows those rules. The only one we didn't do now is the is alive, right? I think we also checked for is alive in attack. I didn't check to make sure we is alive. Do we do that? Yeah. We could try a dead unit, make sure it doesn't attack, right? Because we have code here, we didn't test it. I don't feel good that it works. Should we try one more? I think we should do one more. So this is not alive, doesn't attack. Sure. So to make a unit not alive, we could go and attack it a bunch if we wanted, right? So us attacking them should kill us, or should kill them, right? And then if them tries to attack us, nothing should happen, right? So we should have 10 hit points still. So an actual hit points can equal us not get hit points. Right? Does that make sense? It's a lot of code to test one little is alive here, but all of this is happening right in the attack piece here, making sure that's not getting set, and then making sure we're not actually attacking if that's false here. So let's give that one a run. And that one works. So this is why at some point the business decision has to get made like, all right, you've got enough tests. Time to move on to making new code. But you want to make sure all the code you write works. But someone assigns your paycheck and says, hey, stop spending time on that eventually. So you could go crazy with unit tests. I can make 50 different iterations of this. I haven't really gained anything more now because I think I've exhaustively tested everything I've written now. I've tested this condition, I've tested this condition. Oh, I didn't even test chaotic, that should attack everyone. We could add another test. Probably should, but we're getting that the team doesn't match the team. That's okay. So maybe we do a chaotic attacks chaotic. We could add that test if that's important behavior, right? And the more tests we have there that have encoded our business logic, this is what we were supposed to write, probably the better. But is it worth spending another 5 minutes writing another test for this? Yeah.
How do you know if you roll the code correctly? Like the test.
If it runs and passes, usually. And it's possible to screw it up. Like you can have a bug in your code and a bug in your test and not catch a bug. That happens. But having the tests decreases the likelihood that you have bugs because at least you've tried it to exercise it.
What I'm saying is, what if your code is wrong, but your test is wrong?
Yeah,
so
that can happen.
You that something's right.
Yeah, that happens. It's not fail-proof, but again, in the whole process of writing software, usually someone else looks at it. So this idea of a peer review or a code review, and then hopefully the other person who's looking at it will catch that. Or maybe the quality assurance person who's testing the code before that gets shipped out to production will catch it. Right? In the process of writing software, the software development lifecycle, there's lots of tests that happen. Because the later code gets shipped out, or the later a bug is found, the more it costs to fix. So if I'm writing code and I find the bug, it's pretty cheap for me to fix. It's just a couple minutes.
So let me tell you something. I was working as a test analyst in a company for 4 years. So it's like a team, business team. There's a development team and there's a testing team. So from the business team, they develop whatever the requirements they give, development team works on. They try to maximum do the test within themselves and they do the code to us, like a code application. how to. We test them and make sure whatever the business requirement. So this is how it happens. It's not basically right or wrong. So whatever the business requirement is there, that should function properly. No code is good. Like no code is 100% good. Even towards the end of, that's why any application which you see, it's not like one time done and it keeps on. Let's say Amazon, they say like 30,000 changes they make every day. Every department. That's what the facts say. So no code is good at all. So it's always keeps on going.
Like it's a testing loop.
It all goes on a sprint basis. Every 2 months, 1 month.
Yeah, how often you're going to release your software, and that's why, like, if you can get automated tests and automated releases done,
So
it speeds everything up.
this is what the industry does.
Yeah, yeah. So having tests is useful, and then the next level of testing, right? Having an actual person run tests on it that like it all works together as it's supposed to, is they're not going to call individual functions usually. They're going to say, here's what the business said my code should do. Does it do that? And if I give it weird things, does it fail gracefully? Usually, those sorts of things. If we look at that T-shirt about ordering a lizard, when the QA engineer walks into a bar, do we do that? I like that shirt.
Once that code is done, QA team does like so many test cases, right? Then and do automate them so that whenever developer does some kind of implementation, they make sure that the older functions are working properly. So
Yeah.
that's all things happen.
I always like to joke, because I never did QA professionally as a full-time
was
job, that
curious.
the software engineers are trying to put QA engineers out of a job, and the QA engineers are trying to get the software engineers fired. Like, hey, look, they aren't finding any bugs. You don't need them.
They
And the
were
QA
like-
engineers are like, hey, look, I found all these bugs. Fire your engineers.
Tom and Jerry. The developer is the Tom, maybe the Jerry is the
Yeah.
QA. It's always that the rapport will be there. Any implementation they do, the next day, like we could keep on raising so many bugs and they hate us like anything.
Yeah.
It's like
It's good. So yeah, the later it takes to catch those bugs, the more expensive it is to fix. We've gotten a little bit lazy at it's fast to update software that customers have. It used to be much more expensive back, because I'm an old person, back when you'd get like a CD with software on it. If there was a bug in that software, I'd have to get a new CD. Right? I couldn't go download anything because I'm old. But nowadays you're like, hey, the app says it needs an update, and it updates itself. It still takes time to do that, but the cost of there being a bug is not as high. So the sooner you catch your mistakes, the cheaper it is to fix. Like, even though we can still automatically update apps and things like that. Like apps on our phone update multiple times a week now, because I'm sure it's not new features. So that sort of thing. So having this process is useful, helps make sure that the code we write is good, and this is at the unit level. Right, you can do the bigger levels of tests. You can do integration tests that all the pieces are working together. You can do an end-to-end test. That's typically, or a system test like a QA team would work on. Hey, now we've put it out in a working system. Let's test the full suite of functionality rather than one little unit, one little method, one little function at a time. Right, it's a bigger test.
Is it called task-driven development?
So using unit tests, you can do test-driven development, which is saying, I'm going to code my tests first because I know what it's supposed to do, and then I'm going to go make the tests pass. It's super fun. So like, if you know, hey, here's my methods, and here's what they should return, you could just go write the tests based on that spec.
So you first write the task?
Yep. Yep. Yeah, it's a lot of fun. We already wrote some code. We can do that later. So I don't think we really need tests for infantry, artillery, and cavalry. We could test their inits. It's a little bit boring. We'll do one. How about we'll do one? Let me go to test. We'll make a test here. And then we will test init. Test init. So artillery has a couple values, right? So we'll have, I don't know, expected. Now, I don't even have the max move units, like, I don't know, max move units, expected attack power, expected hit points, and expected range. So then oh my goodness, I can't spell the word expected. There we go. Not that it matters that much, but all right. So the code I'm testing then is just the init. So here's my cavalry equals I got to import. Right? So from cavalry, import cavalry. Can make a cavalry. Now the positions don't really matter much in the team, right? Cavalry.teamus, sure. I guess we could have expected X position. We'll say 1. Why not? We'll put it at 1, 1. Y and expected team, sure. Cavalry.teamus, sure. I can pass it all these things. Expected Y and my expected X. Now I have to go get all those back out. And this is why these are tedious. There's tools that'll like write these tests for you, or just ask the chatbot to write the tests for you. That's probably better. But we could have an actual max move units. My cavalry dot. I don't have a get max move units, so I could go get the max move units. It's not very nice to go and get private values. Again, it's not the end of the world. We'll be okay. My actual attack power. That one I have a get attack power for, right? So usually you want to use your public functions. And actual hit points. Get hit points. And actual range. Cavalry.get range. Right? And on and on and on. Do you want me to do the rest, or is this dot dot dot? Right? And then we'd say self.assert equals my expected, my actual. Right? Dot dot dot. So just going through and making sure that the init gives all those values like we'd expect. Again, one more chance to catch if I have any bugs. Most likely, the problems I would have would be if I'm passing them in the wrong order, right? If I'm not giving the right order of values, if I like swapped attack power and hit points, weird things would happen, right? So that's the sort of thing that might be good to check, and maybe we don't want to give the exact same value for things, right, as we're testing it. Where'd it go? So if I give it, oh yeah, those ones are different anyway, so that's fine. Let's give that a run. Uh-oh. My expected was 10, my actual was 5. Okay, what did I screw up now? My expected range, my actual range. Oh, it was 5. Where did I get 10 from? Did I... Yeah, I don't know why I would have had... Did I change the number? I don't know. Whatever. That's fine. Now let's try and run it. See, we caught a bug. But I guess the bug was in our test, not the code itself. So we feel bad. All right, so that's how we would do the tests there. That would make sense for the project? And then captain, right? We have to test captain because this one is special behavior for attack. That it actually heals the target. All right, so one last test. Go to test, test captain, yes. Test attack. From captain, import captain. So we're going to arrange. We're going to act. We're going to assert. You don't need these headers every time. I'm just adding them in so that we can see what we're doing here. So we'd have an expected hit points. Probably the max hit points of some unit, right? So I probably need another unit because captains aren't going to do any damage to anyone else. So how about just infantry? So it'll be, I don't know, infantry starts with, oh goodness, what do they do? Max hit points 5. So I can say infantry dot max, no, hit points. There we go. Sure. This makes it easier in case that number changes, right? I don't have to change my test. So I can change infantry hit points and not have to go change all my other test places. So I need a, I don't know, us is a infantry given 0, 0 and infantry dot us, team us, and we'll make a them. Is an infantry, team them, and then I need a captain. Right, and I have a captain. Is a captain given, I don't know, 0, 0 and team us. Captain dot team us. Sure. Captain. So I'm not calling the captain code yet. So I'll have us, or I'll have them attack us. Right. So the first attack should go through. When an infantry has 5 hit points and attack power of 5, oh, that's enough to kill it. Shoot. We have to attack something with more hit points then. Let's attack a cavalry. We do cavalry have attack power. Okay, well, let me just do cavalry then instead of infantry. From cavalry, import cavalry. right? Because otherwise I'm going to run out of hit points. So the cavalry should do 5 points of damage and go down to 5 hit points. Then I should be able to heal them back up to 10, right? So after all of that happens, then my captain should be able to attack the us, and my actual hit points then, hit points, should be my us dot get hit points. And then we can assert the expected hit points as the actual hit points. So it should go down to 5, back up. And we can even add like a step in between if we wanted to make sure it went to 5, and it's not just not doing any damage. But we feel pretty good about move. So you can get extra detailed in your tests if you want. I don't know what hit points before captain is 5, right? Then we can have a before the captain attacks. My actual hit points before captain equals us.get hit points. Self.assert equals my expected hit points before the captain and the actual hit points before the captain, right? Make sure it went down and then back up again. Why not? And that one passes. So we feel pretty good. Again, we could add more checks in here because we are checking for is within range and target again. We could check those. Now, I've already tested this function, so I don't think that's super necessary, right? We tested the is within range in the unit, and I'm using the same function. If I were to have the code again, I might want to check it again, right? Because because I've already tested this function, right? We could check that it doesn't heal the same team. We could check that it doesn't heal things that are dead. We could add in more tests. We're running short on time though. We spent a lot of time on this, so maybe we just leave a note. More tests with range. We don't need range, but we needed same team and is alive, right? Just some ideas there, things we could check. So let me go commit this to GitHub.
What was the next project?
Oh, that's right. 0. Give me a second. How about we talk about that on Tuesday? We can give it. We got a little time. We don't have anything to work on. Okay. We'll do that Tuesday because we only have a couple more minutes. Yeah. Yeah. So it'll just be 2 weeks from then.
Is it like 30th was the due date on the canvas for the project 0?
Yeah. So for project 1.
Oh, okay, project 1.
Yeah. Well, the next project. Yeah, we'll work on project. We'll talk about that Tuesday. We'll have some time. All right. Awesome. Any questions about the array-based sequences? Again, I apologize. I think it's super dull. It's very interesting. It's very interesting.
So it's the video you sent the one.
Yeah, it was the video from Tuesday.
What is the next project going to be on? Like just a topic?
Recursion. Yep. Yeah, so we'll revisit recursion. We can talk about the recursion lab as well on Tuesday. There's probably some questions. So getting the Warnsdorf rule, where we're targeting the square with the least number of moves. So ever so slightly tricky, depending on how you want to go about it here. If you just ask the chatbot or looked online, it's not too bad. It's just a couple lines of code. But it like generates another list of moves, essentially, sorted by something. So it's an easy way to do it. All right, thanks, folks.